All right, let's take a look at number 7. It's a little different problem, but it wants to know what's the sine of theta if cosine theta is 4/5 and theta is in quadrant 4. I had a little typo on my paper, but I fixed it on yours. All right, so the first thing we want to do is draw this thing. So we have this angle. Here's the initial side, and we know that the terminal side is somewhere in quadrant 4. That's fine, good enough. So we know that cosine is 4/5. So if you finish drawing that triangle that we just made, there, that guy, we know that this reference angle, it has a cosine of 4/5. So the 4 is adjacent and 5 is hypotenuse because cosine is adjacent over hypotenuse. Okay, that's what this told us, adjacent hypotenuse. Now, we want to know the sine of this. So to find the sine of this, we need to know the opposite over hypotenuse. So we need to know that opposite side. So we can just use the Pythagorean theorem. We're going to do 4 squared. I'm just going to call it w squared equals 5 squared. So when we subtract that, we get 9. So w is 3. So this side is 3. But I want you to notice this is right 4 and down 3. So this should actually be a -3. And now if we want to find the sine of theta, sine is opposite over hypotenuse, so -3/5. Let's try another one like that. We want to know what's the cosine of theta if sine of theta is -1/2 and is in quadrant 3. So here we are in quadrant 3 somewhere, doesn't really matter. We're going to finish drawing the triangle with the axis. And the only thing we know is that the sine is -1/2. So sine is opposite. So opposite is -1 and hypotenuse. Okay, so this is opposite hypotenuse. That negative needs to go with the 1 because the hypotenuse is always positive. And we want to know the cosine of this angle. Cosine is adjacent over hypotenuse, so we need to know that adjacent side. So again, we're going to use the Pythagorean theorem. We're going to do -1 squared. I'm going to call it w again. Doesn't really matter. So we get 1 plus w squared equals 4. W squared is 3. So w is the square root of 3. All right, so root 3. Now, again, think about you're in quadrant 3. So you are left. So that needs to be negative. And down. So those are both negative. The hypotenuse is always positive. And so the last thing here is, I don't know why that won't draw. There we go. The cosine of theta is adjacent over hypotenuse. So -√3/2. So we were able to do both of those problems without even knowing what the angle theta was. Who cares? We were just able to use Pythagorean theorem. Now, something I want you to think about is about the signs, positive or negative, of sine, cosine, and tangent. So let's think about a triangle over here, okay? So remember, this is our point xy. So this was xy, and then that's our radius, whatever it is. And if you're in the first quadrant, these are all going to be positive numbers, okay? So that means that sine is positive, cosine is positive, and tangent is positive. They are all positive here because all of the sides are positive. Now, let's think about a point in the second quadrant, okay? So again, this is a point xy. Now, in this quadrant, the x-coordinate is going to be negative because we've gone left, and the y-coordinate is going to be positive, and the radius is always positive. So when we're doing the sine, sine is opposite over hypotenuse. Y and r are both positive, so sine is going to be positive. But when you do cosine, when you do adjacent over hypotenuse, that's going to be a negative value. And when you do tangent, that's opposite over adjacent, that's going to be a negative value as well. All right, I'm going to erase some of this so that way we don't get too confused. Maybe I'll erase it. All right, so let's take a look in the third quadrant. Maybe I'll even change colors here. Sure. All right, so we're going to think about a point in the third quadrant. Okay, draw the triangle that goes with it. Now, in the third quadrant, you've gone left, so that x value is negative, and down, that y value is negative. So when you do the sine, opposite over hypotenuse, that's going to be a negative. When you do the cosine, adjacent over hypotenuse, that's going to be a negative. And when you do the tangent, opposite over adjacent, those are both negative, which makes it positive. All right, one more quadrant, and then we'll look at a pattern out of this. It'll be interesting, I promise. Well, interesting is kind of I don't know if that's necessarily the word I would use. All right, so again, we're going to do the same thing. Let's draw this triangle, x, y, and r. We're in the fourth quadrant, so x is going to the right. That's a positive, but y is negative. So when we do the sine, sine is opposite and hypotenuse. That's going to be negative. When we do cosine, that's adjacent and hypotenuse. That's going to be positive. And when we do tangent, opposite, and adjacent, that will be negative. All right, so here's what I want you to see about all of this. In the first quadrant, they are all positive, all of them. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. And in the fourth quadrant, only cosine is positive. Okay, and that is always going to be true. So that's something that if you go back up to the last problems that we did, let's find an interesting one. Like number 2, tangent of negative 45, that was in the fourth quadrant. In the fourth quadrant, tangent is always going to be negative. Okay, the sine is going to be negative, only the cosine is going to be positive. There's a little acronym that we use to help remember this. There's a sign hanging in my classroom that you can't see, but it is all students take classes. Okay, all students take classes. And that's just a little acronym to help us remember that all of them are positive in the first quadrant, sine is positive in the second quadrant, tangent is positive in the third quadrant, and cosine is positive in the fourth quadrant. Now, one other thing I want to show you before we end this video, and this is something we're going to talk about next week a little bit more in depth, is if we have a point xy on the unit circle, we can do Pythagorean theorem with it. Here we go. Okay, so I'm just going to, here's that unit circle, not super well. Doesn't matter where we put the point xy. Okay, and just like we were doing, we're going to create that triangle. This is x and this is y. And since it's on the unit circle, that means the radius is 1. And I want to show you Pythagorean theorem says that x squared plus y squared equals 1. 1 squared, which is just 1. Now, remember the other thing that we just talked about is that x, another way to find x, is to do the cosine of this angle theta. Remember, because it's adjacent and hypotenuse. So we could replace this x with cosine theta. Y is the sine of theta. So we can replace the y with sine theta. And that equals 1 squared. So we know that cosine of theta squared plus the sine of theta squared is equal to 1. The way we usually write this is cosine squared theta plus sine squared theta. That way we don't have to write parentheses, equals 1. This is called the Pythagorean or a Pythagorean identity. We have more of these that we're going to talk about next week, 2 weeks. I don't remember exactly when, but it just comes from the fact that these are right triangles and we use a Pythagorean theorem. And it's a really important identity that we'll see all the time next year in trig. So I just wanted you to see it now. So that is our trig functions in the unit circle.